In this example, we are doing a more challenging version of this type of a problem right here. So in this problem right here, we were trying to figure out that if this is the inside piece, that's going to be my chain rule piece. And so I was kind of testing to see if I did the derivative of natural log, do I have a substitution that I can create out of this? So we're going to do the same thing. But first, I'm going to kind of rewrite some pieces that if I have a number, I can pull that number off. I can break this fraction into multiple pieces. So with that, that means I can make, so as soon as I bring the 3 off, that becomes a 1 on the top. And then the dx I'm going to bring off to the side as well. And so I'm looking at a 1 over x times a 1 over the natural log of 9x dx. Okay, so it's going to be a little bit easier for me to recognize my pieces once I kind of break some stuff up. So the challenge is, am I letting this piece or maybe the x be the u, or am I letting maybe the natural log of 9x be the u? Um, and so sometimes you get to a problem where you're going to have to guess and you're going to might be going to be wrong. And that's okay. You got to kind of test the water a little bit. So I'm feeling like if I take this one and do the derivative of, if we do the derivative of a natural log, we're getting a 1 over x. So this maybe lends me to, I got to figure out how the 9 plays into it. But if I take this and let that be my u and I do the derivative of it, am I going to get something like this? And then I have a substitution. So let's test it out. So if I take natural log of 9x and I do the derivative of that, I'm getting 1 over 9x. And then a natural log has a chain rule to it. So 1 over 9x times the derivative of 9x, which is 9, and then dx. So then that is going to simplify out to, those 9s are going to cancel, and you're going to get that perfect 1 over x dx. So here's your 1 over x dx that you can replace with du. So that means we have 3, this piece and this piece, right, are that are going to be replaced with du. And then this becomes 1 over u du. And that's what I'm going to be doing my antiderivative of. So if I have a 1 over u, I'm sitting with this and I'm going backwards. And so the antiderivative of 1 over u, don't forget my 3, is going to be the natural log of the absolute value of u. And then I can sub my u back in. So 3 times the natural log of the absolute value of the natural log of 9x c. So we have the natural log of the natural log of 9x. And if we wanted to test that, we can do the derivative of this, which would be a chain rule, kind of within a chain rule, and it should simplify out to that. So that was a little bit hard over log, kind of recognizing what piece is going to be your u is always the challenge. But that was that problem.